So far as we've practiced solving equations, we've worked primarily with integers. Now this has made things easier for us as we've started learning the concepts of equations. But in reality, we're going to face a lot of equations that have fractions instead. Now, everything that we've learned so far can be applied equally to equations with fractions. Fractions are just one way of writing rational numbers, so we can still solve equations the same way we've already been doing. However, we can make equations with fractions a lot easier with a few clever little methods that we're going to look at. Approach 1. Solve while keeping fractions. When solving equations with fractions, we can still simplify them and use inverse operations to solve them as we would for equations with integers only. So the equation 2/3 of a plus 5/6 equals 4/3 is simply a two-step equation. Now it looks more complicated because the numbers are written as fractions, but we can still solve this the same way we've already seen. First, we'll subtract 5/6 from both sides. Now this involves a little work because we need to write our fractions with common denominators, but we finally get that that is equal to 1/2. Then we need to divide by 2/3. Recall that dividing by a fraction is the same as multiplying by its reciprocal. So we're going to multiply both sides of our equation by 3/2. This gives us the result, a equals 3/4. Next, we'll solve the quantity 2t plus 11 over 4 plus 5t over 8 equals 16/5. Firstly, let's split up the first fraction to put it in a form more convenient for solving equations. So 2/4 of t, which is the same as 1/2 of t, plus 11/4 plus 5/8 of t equals 16/5. Now, like we've seen before, we can combine like terms and have 1/2 plus 5/8 to get 9/8 of t. So 9/8 of t plus 11/4 equals 16/5. We can subtract 11/4 from both sides and eventually work out that this is equal to 9/20 on the right hand side. Like we did before, we can divide by 9/8 by multiplying by its reciprocal, 8/9. This gives us t equals 8/20, which simplifies to 2/5. Approach 2. Eliminate denominators first. In this section, we're going to solve the exact same two equations that we just solved, but we're going to use a slightly different approach to do so. Before we do that though, let's see if we can understand why this approach is going to work. So we have some examples of some fractions, and the first thing we're going to do is identify the lowest common denominator for each group of fractions. Remember that the lowest common denominator is the smallest multiple of all the denominators in the fractions in which we're interested in. So for the denominators 2, 4 and 8, our lowest common denominator is 8. For 3, 5 and 10, it's 30. And for 4, 6 and 12, it's 12. Next, we'll take each fraction and multiply by its lowest common denominator. Now what we find after doing this is that every single product is a whole number. And what that means is we've effectively got rid of all our fractions. Well, normally you can't just do this and decide to multiply a fraction by something to make it not a fraction. But in this particular situation, where we're solving equations, this is incredibly useful for us. The denominator of a fraction can be eliminated by multiplying the fraction by a multiple of the denominator. The lowest common denominator is a multiple of all the denominators in a set of fractions. This means we can eliminate all denominators in a fraction by multiplying both sides by the lowest common denominator of all the fractions in the equation. So this time when we attempt to solve our first equation, we're going to look at the denominators 3, 6 and 3 and identify the lowest common denominator as 6. So we multiply both sides of the equation by 6. Now be careful here, this means every single term is multiplied by 6. But the result is 4a plus 5 equals 8, a two-step equation which no longer has any fractions. We can now subtract 5 from both sides, and then divide both sides by 4 to get the same solution as last time, a equals 3/4. For the second equation, we have the denominators 4, 8, and 5, which gives us a common denominator of 40. Now, like before, every term in our equation needs to be multiplied by this lowest common denominator. Let's be careful as we apply this. For the first fraction, the denominator is 4. Now remember, this 4 is being divided. If we multiply by 40, this has the same effect as multiplying by 10. Now, as we write this down, we're going to include parentheses around the original numerator, 2t plus 11. Remember, the fraction counts as a grouping symbol. We've eliminated the fraction, but we still need to group that original numerator. So we have 10 parentheses, 2t plus 11, close parenthesis. 40 divided by 8 is 5, so the next term is multiplied by 5. And 40 divided by 5 is 8, so the next term is multiplied by 8. This gives us, once we distribute, 20t plus 110 plus 25t equals 128. We can combine like terms to get 45t plus 110 equals 128. And then this is just a two-step equation. We can subtract 110 from both sides and then divide by 45. Once we simplify, we get the same solution as before, t equals 2/5.